Okay, class, in this video lecture, we're going to talk about the Earth and the Moon, how they were formed. Such a nice looking planet. But it didn't always look so nice and inviting. And in fact, as the Earth was first formed, remember the nebular hypothesis, the condensation of all the chunks of matter in a particular region from the sun, the Earth was a pretty hot place due to not only the forces of gravity pulling things together, but also what is called the Great Bombardment. The Earth did not have much of an atmosphere at that time, and so everything that was flying around through space and all of the debris that was being collected as it swept out its path and brought all of the material into the planet Earth led to a constant rain of this debris and meteors, further increasing the temperature of planet Earth. So things were pretty hot, and it would be best described as a molten planet. The next phase after the so-called Great Bombardment, which lasted maybe the first several hundred million years, and is sometimes called the Hadean period in terms of geological ages, in terms of geological periods. But the next phase is what is called differentiation, in which the heavier, more dense metals, iron and nickel in particular, which the Earth has a relatively high amount of iron and nickel, these were pulled towards the center of the Earth, whereas the lighter materials, the lighter minerals, sort of floated towards the top. And eventually, when things cooled down, the top part became the more solid-like crust. We will have chapters focusing on the structure of the Earth in a little more detail, but basically there is a compressed core, which is more solid-like, due primarily to the high density of the core of iron and nickel. Then there is, from that, a molten outer core region. Then above that is a mantle region, and then above that we have the outer region called the crust, which is actually a fairly thin but solid-like sheets, and we'll learn later on that these are actually plates called plate, and we'll talk about plate tectonics. As I said, there wasn't much of an atmosphere for planet Earth initially, but as the Earth began to cool, an atmosphere did eventually form, and a lot of this was due to what we call outgassing. And maybe the primary mode of outgassing was through the spewing of gases trapped inside of the Earth's crust through what are called through volcanoes, and that created the gases that we now think of as our atmosphere. Now, the gases initially were mostly nitrogen and hydrogen and carbon dioxide and water. There wasn't oxygen on planet Earth for about the first 2 billion years, almost half of the total age of the Earth. There was not oxygen on planet Earth. Now, a reason for this, even though there was oxygen in planet Earth, there was not oxygen gas in the atmosphere. And a reason for this, if we go back to our chapters on chemistry, is that oxygen is so reactive that it will combine with the other elements on planet Earth to form some kind of oxide, including the oxide of carbon dioxide, the oxide of hydrogen called water. But it did not exist as molecular oxygen, O2, by itself, which we now have in our atmosphere. Now, as the Earth further cooled, the water vapor in our atmosphere eventually got cool enough to condense into liquid, and we had rain, which filled the oceans and the rivers and the lakes. You could imagine how much rain must have happened in order to form all the water in the ocean and the lakes and rivers. Also, the land masses that we now know did not always exist in the current manner of the continents. In fact, at one time it was thought that there was one single landmass, a supercontinent called Rodinia, that it eventually broke up into other dominant land masses. One of them is called Pangaea, which is a term that you may have heard of, before they broke up into the current continents that we now recognize. Okay, what about the moon, which we can also call Luna? It's sort of its more proper name when we want to distinguish our moon from the moon of any other planet. Well, we think that the moon was formed about maybe 100 million years into the life of planet Earth, that there was a big collision, and we call this the giant impact hypothesis, that some other planetesimal, actually a fairly large one, a Mars-sized planetesimal, perhaps trying to compete with the path being swept out by planet Earth, there was a collision. And as a result of this collision, most of the mass of this Mars-sized planetesimal was absorbed into planet Earth, but a chunk of it also was ejected or bounced off and formed the moon. And in doing so, a lot of what we now recognize as the moon used to be part of the crust and the outer mantle of planet Earth. As evidence for this, there are similar densities between the moon and the outer part of planet Earth. And the elemental composition has a similar ratio of some stable isotopes, such as oxygen and carbon. This again gets down into the details. But the point is that there's evidence that the moon was, part of the moon at least, was a chunk of planet Earth. The mass of the moon is a little over 1% of the mass of planet Earth, but it's still very important to us. Now, other planets have their own moons or natural satellites, and just so that you will have heard of some of these, this shows some of the larger, more well-known moons or natural satellites of the other planets. Io, Europa, Ganymede, and Callisto are 4 of the larger moons or satellites of Jupiter. Actually, Jupiter has close to 80 recognized moons or satellites. Titan is the largest natural satellite of Saturn. Saturn also has about 80 moons or natural satellites. They were harder to detect, and as you may know, because Saturn has, in addition, has this set of rings around it. And Triton is the largest natural satellite of Neptune. Now, how about Pluto again? Pluto is considered a dwarf planet, but there are other dwarf planets, most notably Eris and Makemake and Umay and Ceres. Pluto is much smaller, as we said earlier, about 0.2 to 0.3% of the mass of planet Earth. We'll see in the next slide that its path, that as it revolves around the sun, is tilted a great deal from the path of the other planets, which is one reason why it was demoted from being one of the planets, also because of its size. Pluto orbits the sun every 248 years. So it's pretty far out, so you might imagine it'd take a long time to orbit the sun. It has moons itself, and it has one moon that is Charon, it's called, which is nearly as large as Pluto itself. It has a total of 3 moons. It's now thought that Pluto was an asteroid that was or a comet that was sort of captured after the formation of the other planets. That's why it's no longer called one of the 8 planets, but is now designated as a dwarf planet. It's actually called a Plutoid, so it has its own category. Another dwarf planet is Eris. Eris is actually larger than Pluto. It orbits the sun every 560 years. It's a little bit further out. It has a moon. And let me show you the orbits, the paths of Eris and Pluto. If you look near the center part where we have the sun, and then these rings are the patterns for the other planets. And here we see this one would be Neptune, the furthest out of the other 8 planets. Then Pluto, its orbit is a little bit off kilter, a little bit more elliptical. Makemake, also a little bit off kilter and more elliptical. And then Eris, a little bit more elliptical and off kilter from the 8 recognized regular planets. So that's why some of these are called dwarf planets and are in a different category than the first 8. Okay, again, we'll pause and have a little quiz, and then come back later and talk about asteroids and meteors and comets. So, a lot still to come.